Large-scale experiments on stratification were carried out at the Hydraulics Laboratory of the Colorado State University Engineering Research Center. For the experiments, a 4-foot wide flume measuring 60 foot long recirculates 1,000 cubic feet of water and 8 tons of a sand mixture. This flume provides a continuous supply of coarse and fine sand particles under steady discharge conditions.
Consider a typical delta sketched on the board. At the initial time t1, the delta is comprised of 3 parts: the top set, the foreset, and the bottom set slope at initial time t1. Over time, the coarse particles rolling on the bed slide down the foreset slope of the delta and accumulate as the delta progresses in the downstream direction. Finer particles rolling on the bed settle and form a layer of primarily fine particles. The particles in suspension are carried through and deposit on the bottom set slope of the delta. After a certain time, we get a second bed profile at time t2. The sediments accumulated on the bed from time t1 to t2 define what is called a layer of sediment. A layer of sediment is the accumulation of sediment between the initial time t1 and the subsequent time t2.
This typical delta gradually progresses in the downstream direction A close look at the top set slope in slow motion clearly shows a laminated deposit of finer particles. The thickness of the top set deposit decreases in the downstream direction as the foreset slope of the delta is approached.
Over a long period of time, the accumulation of sediments displays clear stratification, with fine particles on top, coarse particles in the middle, and fine particles on the bottom. It is important to understand that the chronology of the formation of the deposits depends on the layers and not on the strata.
Increasing the flow depth while keeping the discharge and the supply of sediment unchanged results in more complex sedimentary features. Substantial deposits accumulate with features including deltas, dunes, and ripples at various stages of development. A dried delta, viewed from the flume sidewalls, displays clear stratification characteristics in terms of superposition of deposits with similar particle size distribution. A cross-section is cut through the delta to examine the primary features of deposits of sediment mixtures carried out under steady flow and a continuous sediment supply. The cross-section displays a clear superposition of strata of fine particles in white and coarse particles in black with clear lamination. Looking at the cross-section of superposed strata, it is tempting to conclude that the strata correspond to successive sedimentary layers, that they result from discontinuous sedimentary periods, that each strata is younger than the one underneath it and older than the one above it, and that all points of the same strata have the same age.
In this experiment, researchers use a sandbox submerged in water to simulate how ocean currents carve underwater canyons. They pour a stream of heavy salt water over the sand in 10 stages and lower a downstream barrier before each stage. canyons start to appear after about 30 minutes. The canyons get deeper over time, and about halfway through, ridges begin to develop. The canyons start to build their own drainage networks as the experiment goes on. As the three largest canyons in the center redirect the flow of water, those on the outer edges of the box disappear. The experiment shows that submarine canyons are self-similar. This means the entire canyon structure has the same shape as its parts.